Hi guys, this is a quick review video lesson on linear functions. You spent the large majority of Algebra 1 looking at this particular type of function. Remember, linear functions have a constant rate of change, which means when you graph them, they come out as a clear horizontal, vertical, well, vertical wouldn't be a function, but it'd be linear, or diagonal shaped line. So linear functions can appear in one of these three forms. There is slope-intercept, which is y equals m times x plus b, where m represents the slope, also known as rate of change or constant rate of change when we talk about linear functions, and b represents the y-intercept. And remember, a y-intercept is a point, so if you were asked what the y-intercept of this equation is, you'd say 0, comma, b. So whatever that constant is, that's your y-intercept. Point slope form is y minus y1 equals slope times x minus x1. We probably spent the least amount of time on this in Algebra 1, but it's a really handy form because to write something in point slope form, all you need to know is any point on the line and its rate of change. The last form we learned in Algebra 1, and I should go back here. Let's go back to point slope. M is still the slope, or your constant rate of change. But then the x1 and y1s, these make up the point on the line. So the point on the line would be x1, comma, y1. That would be your point. Notice how even though there's a subtraction sign, the x1 is positive, and even though there's a subtraction in front of the y1, that is also positive. Point slope form is the one that we discussed how because of the form it's arranged in, it's almost opposite your gut. You would think it'd be a negative x1 and a negative y1, but it's not. The last form you learned was standard form. Ax plus by equals c. And that's a handy form if you want to find your intercepts, because you could plug 0 in for x to find the y-intercept, and you could plug 0 in for y to find the x-intercept. Standard form didn't really appear on the circuit review that we looked at, and it's probably the least used of all three forms. So graphing in slope-intercept form. Remember, in order to graph in slope-intercept form, you need to know your y-intercept first. So in this case, my y-intercept is 0, comma 7, and then your rate of change. So remember, the y-intercept is the constant being added or subtracted from the end, and your slope, or your constant rate of change, is the coefficient of your independent variable. So, slope. So let's graph this one together. So actually, I'll pick a color just so you can see it a little more clearly. Okay, so I'm going to go up to 0, 7. That's my y-intercept. And then my slope is negative 2. So because my slope is negative 2, if you remember, it's really negative 2 over 1, where negative 2 is your rise and 1 is your run. So when I go to graph this, I'm going to start at my y-intercept of 0, 7, and then I'm going to go down 2 over 1, down 2 over 1. And I hope you can quickly see the importance of using grid paper in graphing. Unless you're provided with a worksheet that already has a grid on it, the expectation is that you use graph paper. And I can get you some if you need some. So this is how you graph in slope-intercept form. So we're still on slope-intercept form. So this is still your y-intercept. So in this case, your y-intercept is 0, comma, negative 8. And again, the coefficient of your independent variable, in this case the x, that is going to be your slope. So m equals 3 over 4. Remember, m represents slope. So we're going to start at 0, negative 8 right here. And then we're going to go up 3, 1, 2, 3 over 4. Up 3 over 4. And you can actually go backwards too. You go down 3 over 4 And that should make sense because when you go down 3 over 4, you're still making this nice, clear, straight line that has a constant rate of change. So now we're going to do some graphing in point-slope form. So when we look at point-slope form, the coefficient in front of your independent variable, that is still your slope. In this case, our slope is 2 or 2 over 1. And then this point, I'm going to try to figure out how I can not write on what you need to read. This and this is going to make up the point on your graph. So because it's a plus 3, your point is negative 3. Because it's a minus 1, it's a positive 1. So when you extrapolate or pull out the point from a point-slope form equation, remember the first coordinate's always an x, first part of the coordinate is x, and the second part of a coordinate is y. So let's start with that point. I'm going to start at negative 3, 1. Then I'm going to go up 2 over 1 because it's my rise. Let's try one more of these. So we look in front of our independent variable. Its coefficient is the slope. So in this problem, the slope is negative 4 or negative 4 over 1. Then the coordinate point you can pull out of your equation. We're going to pull out our x first and then our y. So our x is a positive 6 and our y is a negative 5. So I'm going to start at the point 6, negative 5, and then from there I'm going to go down 4 over 1. And remember, you can go do the opposite. You could go up 4, left 1. You just need to make sure that it forms a nice, clean, straight line when you're done. If it doesn't form a nice, clean, straight line, which mine's been straighter, then it's probably a sign that you either went a little too high or a little too right or left when you start graphing points. So now let's talk about writing equations, giving a point and a slope. So you have two different options for doing this, and because some of you had me, some had Mrs. Davis, some had Mrs. Thompson, or maybe it was just Mrs. Davis and I'm not sure, but you've had different teachers, so you may have seen this done different ways. So you can either use slope-intercept form, or you can use point-slope form. I'll show you how to use both in this example. So let's say I wanted to use slope-intercept. My slope is 3, so I'm going to plug 3 in for the slope value. And then my point is negative 2, 4. And remember, the first part of your coordinate is your x, and the second part of the coordinate is your y. So if I plug 4 in for y and negative 2 in for x, I will get that my y-intercept is 10. So doing it using that method, I would get that y equals 3x plus 10. You could do the same thing using point-slope form. You would plug 4 in for y1, 3 in for your slope, and negative 2 in for your x-coordinate. So then at this point, you're just doing some simplifying. So x plus 2. The AP test actually lets you end here if you're on that track, but all you have to do to simplify is just to distribute your 3 and then add 4. And look, either way we did it, we got the same exact equation. It's your preference. So this is very similar. This problem, you're given 2 points instead of a point and a slope. And so in order to write an equation, no matter the form, you've got to know that slope. So the first thing we're going to do is find slope. And if you remember from Algebra 1, slope was always change in y over change in x. In other words, you're going to do y2 minus y1 all over x2 minus x1. Okay, so I know that 6 minus 4 is 2, and 1 minus negative 2 is 3. So my slope is 2/3. So just like we did on the previous slide, you can either use slope-intercept or point-slope form. You could pick either of these points. I tend to like to pick the 1/6 version just because there's no negative sign, so there's less room for error, but it's your preference. So I'm going to use slope-intercept only because I feel like you guys are a little more comfortable with that. So I'm going to start by plugging in, and again, I'm going to use this point. It does not matter which one you use. I just picked the one that didn't have a negative sign, trying to minimize that error factor. So I'm going to put 6 in for y, 2/3 in for slope, and 1 in for x. So I'm going to get 6 equals 2/3 plus b. If I subtract 2/3 from 6, I get 5 1/3, or if you prefer, that's equivalent to 16/3. Either way, you need to have an equation. So your equation is y equals 2/3 x, and you can either leave it 5 1/3 or change it to 16/3. They are equivalent. It does not matter which one you choose. So this looks different, but it's really just like the last slide. Going all the way back to Algebra 1, for some of you it's been a while, most of you it's been a while. This is function notation. And function notation tells us if 5 is our input, 1 is our output. In other words, f of 5 equals 1 is really just a fancy way of saying the linear function goes through the point 5, 1. Same thing with the 2 and the 10. So just like we did on the last slide, I'm going to find the slope between my 2 points, y2 minus y1 over x2 minus x1. So I get 9 over negative 3, which is negative 3. And I can choose to use either slope-intercept or point-slope form. Either will get us the same equation. I think this time we'll try point-slope, just because we did the opposite on the last slide. So let's say I were to use this and this. I would say y minus y1 equals slope times x minus x1. Then I'm going to add 10. And that's my equation. So this last one is applying. And applying, you guys tend to skip it. You skip it because, well, it has words. But you actually need to read, especially in algebra. So make sure you take your time and read if they give you a verbal prompt. So Darry-Den charges $2.85 for a single scoop and $3.95 for a triple scoop. Assuming a linear relationship between cost and number of scoops exists, find the formula for C of n, the cost of a cone, based on the number of scoops. So let's take what we know and rewrite it as coordinates. So I know the number of scoops is my independent variable because the more I order, the more it will cost. So each of these coordinates are going to be number of scoops and then cost. So if you look at a single scoop, we could say, well, if we get 1 scoop, it's $2.85. And if we get 3 scoops, it's $3.95. So just like in the last few slides we did, I'm going to say, well, I got to know my slope first. So $3.95 minus $2.85 all over 3 minus 1. And so $3.95 minus $2.85 is $1.10. And then just like you did back in Algebra 1 a whole lot of times, you're going to say, well, what is 1/10 divided by 2? Well, that's 55 cents. So my slope is 55 cents. Now, when I look at this, I notice that if my slope is 55 cents, I want to think a little bit and said, is 285 plus 55 cents 395? It's not. And so what that tells me is they're charging us for a cone. And when we find this y-intercept, we're going to be finding the price of that cone. So there's decimals everywhere, so it really doesn't matter what form you use. I'll go ahead and switch it up again and use slope-intercept. So I'm going to say, well, I'll use this point and that slope. So I'm going to say 285 equals slope times my x value plus b. 55 cents times 1 is just 55 cents. And so then I get $2.30 as my b, as my y-intercept. Kind of an expensive cone. Better be a really big waffle cone dipped in chocolate and sprinkles if I'm going to spend $2.30 on that cone. So it asked you to write a formula. Remember, a formula and an equation are pretty much the same thing. So then you're going to end up with a final equation of y equals 55 cents times the number of scoops plus $2.30 for the cone. So this is a perfectly good equation. That being said, it did ask you to find the formula for C of n. So it's going to look exactly the same, except instead of an x and a y, it will have c's and n's. I hope this helps you continue and finish the circuit that I left for you. Try not to overthink it. You've done all of this before. I am confident that you could figure this out.